My name is Filipi Pires, and today we're gonna talk about malware hunting, discovering techniques in in malicious PDF, right? So this is my contact at Twitter at Filipi Pires, my contact and social media. So we can find here some in my webpage. We can find there some talks that I made in some events in English, Spanish, and Portuguese language. My GitHub here, Philip86 in my LinkedIn. So if you'd like to exchange something with me or send some questions, I'm totally available, right? So let me introduce myself. So I'm security research at Sapporo. Sapporo is a company from Switzerland, and I'm responsible for creating attack modules for this company, actually for the product of this company. And I create this. I create the design of the attack and send to the developer team, and this team putting this in our product, right? I'm a founder of the Black and White Technology. It's my own company. I'm advisor and CEO of this company. It's a consulting company responsible for provide services, consulting services actually, and for a PAN, privileged access management, SOC, security operations center, for analysis, pen testing, and so on and so on. I'm a developer advocate in different projects. First is Hacking is Not a Crime, very known in US, and not only US, but in Europe. And I'm advocate of these projects. The idea behind of this project is to talk more about this concept in calling hacking and how important it is to spread the message for many people, because the idea is the hacking is how you can use your creative mind to help organization, to helping companies protect their solutions, their organization, the product, and not only that, but using your creative mind. To be a hacker is to using a lifestyle, right? So how you can using your creative mind in your life, okay? Not how the TVs or the newspaper using this word or a bad to a bad guy, right? So that's the idea behind of this project. And I'm advocate of the Senha Segura. Senha Segura, it's a global company from Brazil, by the way, responsible for providing different solutions for a PAN, a privileged access management, and different authentication process actually. And I'm ambassador of the Sneak open source project, right? So this is a solution to protect the company actually producing a SAST solution, a statistical analysis coding from the developer process actually. Not only that, but SCA analysis composition, scan analysis composition actually, looking from the libraries inside of the code. And I'm ambassador of this project, right? And I'm instructor, writer, and reviewer those three magazines in Europe: Pentest Magazine, Hack90, and Forensic. And by the way, I am a instructor of the specifically course about the malware attack with the Q chain in Pentesting Magazine. So if you'd like to know more about that, so you can send them a message, right? So that's some information about me. And before to talk more about technical stuff, so it's important to put all those peoples in the same page. And first of all, I would like to just to simple explanation what is a threat is according this ISO is defined as a potential cause of an incident that may cause harm to the system and organization. But what does that mean, Philip? Basically, maybe is a software attack or a specific exploitation about attack in software is a kind of a theft intellectual property. So if you produce some code or some product, or if you have some intellectual property, or some attacker or a threat actor try to theft this intellectual property, so it is a threat. Another is identity theft. So for example, if you have an organization and some user has a specifically authentication process or identity to authenticate something, so it's something about the theft of this specific identity, it's a kind of threat. Sabotage, it's another part of this the threat, because if someone talk about your organization on Twitter or other social media, for example, to try, cause some damage in the image of your company, it's a kind of sabotage. It is a threat, okay? And information distortion are example of information security threat. It's just a simple definition. Why it's important to understand that? Because we are talking today about the malware and how you need to looking from these and how you can look in more deeply about that. So malware is basically its acronym of the malicious software. So it's a potential threat. So because of that, it's important to clarify what is a threat. Not definition from Flip, is definition from these eyes. Okay. So let's talk about this simple flow about the malware analysis, okay? So first of all, we have a possible thread or artifact or a sample. So this is the first step, the identification step, right? So as you can see here, we have a malware. It's acronym of the malware malicious software or maldoc, malicious document, right? So remember, you receive to analyze a specifically artifact or sample. So you need to understand if he is a malware or it's a maldoc. Depends of the binary or the extension. Not only that, but many of the factors, not factors, but points that you need to analyze. And after that, you need to choose what the best methodology you use when you analyze something. Like you can use a statistical analysis and dynamic analysis, two different approaches. Okay. So my recommendations to you when you perform something like this, it's important you write this like about all those steps that you are analyzing when you make something. For example, you have received this artifact, you need to register all those steps, because when you do that, you can understand about the steps that possible attack using this attack. And not only that, but you can produce something like a report. And this report you can present, for example, your manager, your coordinator, your tech lead, or you can produce some article, for example, about your studies, for example. It's another interesting point. And not only that, but you can create a specifically improvement, not create, but you can help your organization, your company to improve defenses mechanism. Because when you understand what kind of technique used by the attacker, you can understand what kind of technique this threat actor or this attacker using to bypass the security sensor in your organization, like a firewall, like IPS, like IDS, like a possible sandbox, or other tools that you have in your environment, or antivirus, EDR. So you can understand the technique used by the attacker to bypass those solutions. And not only that, but you can suggest this improvement for your defenses mechanism. And you can creating this good word called CTI or cyber threat intelligence. You can build it in your organization. I know that it's not too easy to create this if you're a small company, but nowadays we have many tools to help you to give this information. Like for example, MISP, it's a malware sharing platform that you can use in an open source project, by the way, using, for example, Elasticsearch to correlating the logs or other thing like this. So you can create these intelligence in your organizations. And you need to strengthen cyber resilience. You need to have this resilience because the threats are changing all the time. So we need to calculate. Of course, it's difficult. Probably you can using some tools to help you to calculate the resistance against the threat in your environment. But remember, this is a defensive approach to understand how you can use in the offensive mindset, okay? So this is the simple flow using in our analysis, in our studies. So remember, this is the first step, the statistical analysis and dynamic analysis. Probably you already heard about that. But if you are new here, it's important you understand those differences. So simple like this, what is a statistic analysis? When you talk about the malware analysis, usually is the first step using in the malware studies. Why? Because the statistical analysis describe the process of analysis of the program code. It means that you will looking more deeply about the structure of the specific code. When you receive the binary, we need to look more deeply about that. Or you can find a specifically function important by the DLL using this attack, or what kind of DLL will this specifically binary will using your system operation to executing this attack in this specific environment, right? So the program itself doesn't run in this time. So because of that, it's more safe when you analyze, because you're looking from the behavior, not behavior, but you're looking the code, the program code. So maybe you are thinking about the reverse engineers and where is the reverse engineering here, Filipi? Basically, reverse engineering, if you are new here again, is a technique that you can use inside of the statistical analysis. Not only that, but you can use it in dynamic analysis. And I will explain what the difference between statistical and dynamic. But it's important to understand. Before to looking deeply about the reverse engineering, you need to understand those bases, right? So what is statistical analysis, what is dynamic analysis, how the tools can help you, how the structure of the binary works. And after that, you can look in more about the reverse engineering, to looking for debuggers, looking for assembly code, and so on and so on, okay? So let's talk about the dynamic analysis. This is the second methodology that you can use in our studies, right? So dynamic analysis based on behavior. In this case, basically is the interactions that the malware or maldoc has when is executed in this environment. Basically is the runtime analysis. Remember, so you have two approaches: no runtime and runtime analysis. One is a statistical analysis that you can look in from the structure of the code, the functions, the DLLs, libraries, and another it's a runtime. So you pick up the malware, you put in a specific environment, controlled environment, remember that, and you will execute itself inside of this controlled environment. You will see the behavior, and after that you check if it's malicious or not. And by the way, it can be easily automated. And basically, we have a specific concept calling sandbox. That call it sandbox actually. Maybe you already heard about what is exactly sandbox. Sandbox is a specific environment. Basically, it's a virtual machine. When you talk about the more analysis or to analyze or investigate, threat hunting, so on and so on. Basically, you have the malware here. You execute inside of this specific environment, and you see the behavior. But it's not only virtual machine. To see if this binary is malicious or not, we need to have inside of this sandbox engines to see the behavior. Basically, it means probably you already heard about what is VirusTotal. Is antivirus scanning. You have the binary. You putting this inside of this antivirus scanning, and based on many engines inside of this antivirus scanning, you can see if this malware is malicious or this is the sample actually is malicious or not. So based on this engine inside of that, right? So sandbox, you need to have the same concept. You need to have this engine inside of that. For example, you have many different open source projects like Kuko and like others. So now I will show you during these presentations, right? So remember, sandbox is not only virtual machine. You need to have this engines inside of that, right? So, okay, before to talk about the structure of the PDF files, we need to see more about the structure of the binary. It's important to clarify those differences, okay? So let's talk about that now in my virtual machine in live code here to you. Okay, so sorry for that. So I have here many different samples, and some samples of this probably is malicious and other not malicious. So we need to check this and to see the difference between and one file or another. So let's check first of all. Remember the flow identification step. You receive this binary, you need to analyze that. So I have here the Amazon file. So I will using file command to see what kind of type of this file is, right? The second file that we're using, I will check is Amazon docx, sorry, is a Microsoft Word, is almost the same. Let me check my friend Bill here. I have a file Bill, is a PDF file. Let me check here malware.python. Maybe it's a Python script. Yes, it's a Python script. Let me check the sample. PDF is a sample, and doctext is a text, but it's a Python script, but with a difference. And another is a tar PDF, is a PDF file. Okay, so take a look at this. We have a different binaries here, different files. So remember, you receive this in your position. Let's suppose that you are an analyst, researcher, more analyst, or whatever. So you need to look in more deep about that. So, sorry, this is my point here. So what is important to see here in this conversation, right? So first, we need to understand if this file is really a malware or not. Let me check here the file malware.python here, for example. Okay, let me read first. I will not execute itself, but it's not a malware actually. Let's check here. So let me try to execute here like a Python 9 and malware let's see here. Okay, so it's a simple code in Python. Take a look at this. It's a Python script. And if you see here, basically this is some information that we have in the beginning. And here we have another file. And by the way, if I change here, let me manipulate something here in this file. Okay, let me cut here. And I will save once again. And I will try to execute again the same Python 39, not 39, Python 3.9, actually, malware Python. And take a look, this is the same, you see? So if I'm using, once again, file, take a look the difference. So here we have a malware, we have this Python script, and we have here ASCII text executable. But here I changing something in the beginning. I cut this part, as you can see here, and we changing this information. So file, identify the type of the file in a different way, if you see here. So let me change other thing here in this file. If I try to, let me manipulate once again. Okay, let me put here PDF, or actually not PDF, %PDF, I think is better, 1.7 maybe, or I can use dash here, I think it's more. And I use save. Yes, and let's check if what happened here. Wow, take a look at this. So now we have a PDF document. And if I try to execute once again in Python, we have a problem here because I have this syntax problem, okay? Because now the file types is different, is PDF. So take a look at this. I have here PDF ID is a tools from DDA Stevens, and I have a view here, and I will perform this, perform these tools executing here to analyze and specifically to search for some simple or some information inside of this PDF, okay, PDF ID. So if you see here, I have a difference object. I will explain the difference between this during this conversation, but just to show you something, let me using the same PDF ID for a malware.python. But Filipi is not a Python, is an extension, and I executing something, but take a look at this. Now this tools PDF ID identified this sample has a PDF. Even this binary having another extension, you see? And take a look at this. And let me check other, let me change something. Move malware doc to malware doc PDF. I will change the extension, PDF ID, and I will try to see is the same. But if you see, I executing Python once again. Now, once again, I will show you the content of this is continue to be the same. Is the same content, right? But when I try to using PDF ID, these tools identify has a really a PDF file, you see? And file, the same case, is a PDF document. I manipulate something inside of the binary. So my question to you is, what exactly information I am manipulating inside of this binary? So think about that, okay? So let me change other things here. So nano malware PDF again, and I will cut here and I will save once again. And now I have the same content. I just cut in the beginning of the information. Let me try to execute in Python once again. Probably we will have some problem, but I will try malware doc PDF. Let me try to execute. Probably I received some error. No, we don't ever error here. Why? Because the extension is different. So what happened here? So if I try once again, oh Jesus, now we have an ASCII text. And let me manipulate other thing here in the beginning of this file. Let me return here once again, sorry. And this is specifically being Python. I will copy here. Let's check here. I will copy this, as you can see, okay. And I will manipulate once again this file. enter. I will pass here. As you can see, I will save once again. File malware. Take a look this. Wow, it's a Python script binary. Let me try using Python once again. So probably works now. Continue works because so I need to write the correct way. So works here. So I changing here something and I will try again. Works again. So let me using PDF ID because it's a malware. It's a PDF once again. And take a look this. Wow, it's not a PDF document. Take a look this. So something happened here. That's the point here of this object of this conversation today. So I am using different tools to investigate and to see the, remember, I received this, remember in your situation. So you work in your company, you receive this file and you need to analyze that. You need to use, and I'm suggesting it, you should use this tool in your analysis, but you need to understand how each tool works. So here, let me explain about the file command. What kind of information, remember about my question, what information file you uses to collect this information inside of the binary? Here is the information collected by the file, okay? So this file have a magic number. Probably if you are, if not a beginner, if you are a senior, a planner, a medium guy, a medium analyst, or if you are a senior, a specialist, or I don't know, principal. You obviously you know about that, about what is exactly magic number, and each binary has a specifically magic number. Some binary is difficult to manipulate. I made some manipulations actually in Python code and PDF. It's easier in this case, but file see in each binary the magic number. Basically, this is important information they looking for this, and basically the file tools, actually this binary, this executable inside of the system operation, the file using specifically database to find those information, and those databases is here inside of this specifically path inside of the system operation. But of course it's compiled. Because of that, you cannot see this information inside of that, but I download this information. This explanation I using by another researcher, my friend Fernando Mercedes. He has a specifically video explain many details about the file, but in Portuguese language, unfortunately, but probably you can use in subscription to see. But I collect the idea behind of this from this video, basically, Fernando Mercedes, okay? And I download the file database to share with you about how this works, okay? So if you see here, I have many different database used by Unix platform, right? So if I cut here PDF, for example, you can see here how many informations, rules, and strings the file command using for a magic number, okay? That's important thing here, okay? As you can see here in the beginning, if you see here %pdf dash, this is the string that you can see in the beginning. So if you read for a Python, for example, take a look this, we can see here the beginning of the information. You see some information you can see in the beginning of the code, strings and other things like this. For example, like user being Python and others. Of course, not only one, but more than one that you can find in the specifically database that you can see here. So that's very interesting. So let me see, for example, a JavaScript, one of very interesting thing. So if you see here in the beginning, dash being node, let me copy here and manipulate the last time here, our document here. So let me return here in the malware folder, nano malware PDF, and I will cut here and I will paste, and let's see what happened. If I can do this, the last one, file malware, take a look this, and pow, we have a executable. In this case, they use in a different way, but if you see, now we have a JavaScript and different way because a script executable. It's very, very interesting. So if you see here, other is a root, malware, file, magic, and what is another? Magdeer, oops, Magdeer and JavaScript. Yeah, JavaScript. And you can see here Node.js, for example. Let me copy, manipulate once again, paste here, and I will cut low just to put JS in the end. Actually, file malware, you see, is a Node.js script. So it's very important thing. Other thing interesting here is about this informations about the structure of the binary. Of course, I will talk more about the PDF, but I will explain more about that, about the structure. If you see here in the manual, take a look. This information is interesting here about the ELF. We don't have a time to talk about the ELF structure or PE, portable executable, but here we have a specific information about the format of the ELF, the structure actually. So how is the difference, or how you can find the array inside of these, how the information you can find these, for example. Let me copy here just to show you here in this presentation. So let me locate here, and I will pass here. Oops. Let me find here is headers is where is located here is okay, is here user, it's here. So I will copy here and I will show you simple. This not better. No. Best. And take a look this file defining standard ELF types, structure and macros. You see, very, very interesting and useful information. Sorry, and here you can see how many bytes you have divided in specifically a structure of the ELF. This is the first one. The first array called, for example, e-identity is a first array that you have the 16 bytes, and this specific array you can find the magic number and others information. Again, we don't have a time to explain many things here, but it's a topic for another talk, okay? Just to show you. So, oops, let me here. No, okay. So let's talk about the PDF structure because it's pretty important part of our presentation. So we have a physical and logical structure of the PDF. So usually you have 4 parts when you talk about the PDF, okay? So we have a header. It's very common in many different binary. We have a body and cross-reference table and trailer. Let's look more deeply about the 4 parts inside of the PDF, okay? So we have a specifically version header here. We have inside of the body, we have a page, image, and fonts, like a shiny thing is inside of the PDF. In cross-reference table, we have a specific locations of the object, even the file for a random access, okay? It means that we have a specifically structure of this PDF. Just let me share with you here. This is my GitHub basically. So let's go to the DD here, Stevens. Okay, this is the guy, the researcher, DDA Stevens, sorry. Here's the blog, his blog. We can find many informations about PDF and other structure. I would like to share a specifically picture. Okay, you can find here, but I think it's more easier. So here you can see PDF tools. It's a small letter, but it's very nice tools that I'm using here in our conversation. Here is the fundamental elements. I think we can find here the information that I would like to share with you. Fundamental elements. Let's see if it's here. And I think yes, it's here. So it's old, but the structure is the same. You see? So take a look at this. The header. So remember, the magic number is the header %PDF dash. So here is the old version that you can read. Here is the different objects that you have inside of this specifically PDF and cross-reference table, okay? 4 parts. And here is the most important to see. how the structure works of the PDF. Take a look at this specifically picture because it's important. So here is how the object PDF works. So we have here the root object is the main object, and you have a two child object, right? Object 2 and object 3. So if you see in this picture, for example, those these two objects is totally linked or referring this specific object 1. You see like a tree, okay? And this specific object, object 4, is not related on this object, this reference object 2, but only reference 3, like object 3, like again, like a big 3, if you think about that, okay? So you see how this referencing each object in another object. So this is very important you understand. Why? Because, for example, let me explain about the PDF ID. In this case, bill is a one of this. Because take a look at this. We have here 44 objects. So let's check PDF Thor. It's another. How many objects? PDF ID. How many objects we have here? So in this case, we have a 16. We have a 18 objects. So remember this picture. So each object is connected in the root object and other child object. Remember that. It's very important you understand that, because in depends of the specific PDF, we have more than one object to analyze. Okay, so that's the point here of this specifically structure, is a location of the object within the file. Not only that, but you have a specifically streaming. It's important part, as you can see here. So we have here 16 streaming to analyze. So if you see, for example, PDF ID in view, I think we don't have any. In this case, we have 8 streaming. Usually the streaming is part of important that attacker using to put in something malicious inside of that. So that's that's important thing, interesting, okay? So, and the trailer basically is a locations of certain object within the body, okay? So you have a part of this object within the body that's a shiny things like a font image, but usually you have some links like URLs, okay? So when you receive some PDF, you click in this URL, you redirect this access in a specific web page, for example. It's a part of the trailer information, okay? So let's go to the specifically investigation that I made when I receive a specifically PDF. Let's go through this step by step. So I receive a specific object, and I will receive the CVE ID. It's a resume actually. So it's very common for recruiters, okay? So remember, this is a part of important to identify if this object is a PDF or not. Of course, just to show you that's the important part. Remember, in the beginning of this conversation, I explained you about how important you understand these bases. Again, probably you are a senior. If you are a senior or a specialist, you know about that. But if you are a beginner or starting to studies of the malware analysis, you need to understand those bases. This is very important, okay? So first of all, I check the PDF ID to see how many objects I have inside of this PDF, how many streams I could have, and some possible suspicious behavior. Okay, so I have here 15 objects, 2 streams. Not only that, but take a look at this, very interesting. The 5 reference of JavaScript, 2 in JS, 3 in JavaScript in 1 open actions, but we don't know what is exactly open action, right? But you need to check this. Okay, cool. So the second tool that I'm using here is a PDF-parser. It's another tool from the DA Stevens. So we can use in here the -s to see a possible specific information that you can find here. So I said -s JavaScript to check. Remember, we have 3 references. So first of all, in object 1, the second reference object 7, and third object is object 12. Remember, 3 JavaScript. And JS, remember, 2 reference. So if you see here, object 12 and object 1, others 2. So I'm using 2 different tools to check the same information. You see? So my idea here is to show you those the same informations in two different tools to check how important it is to understand how the tools works and what kind of information you can find this. The second flag or command that I'm using here using PDF parsers is dash, I think it's W, or yeah, W, is to find for a raw output data, because my idea here is to looking more deeply about the data, not only, but about the possible streaming, right? Or to see more information about that, to read our raw data. Okay, first of all, we have an object one, and take a look at this interesting information. Remember that. So object one, the root, and you have a reference in object 2, 3, 4, 5, 6, and 7. Remember this, not this, but this picture, object 1 referring 7 until object 7. Exactly, that's correct. So remember this picture, object 1, 2, 3, 4, 5, 6, 7. 7 objects totally referenced, or not referenced, but linked on a specific object 1, as you can see here in this demo. Okay, so because of that, it's important to understand this flow. This flow about that. Sorry for this cough, but because I have a COVID a few weeks ago and I still have some problem. A few weeks ago, no, in the last week actually. And okay, let's continue. So if you see here all those objects, so we need to analyze each object to see. And take a look at this. We have a specifically open action linked with this specific JavaScript. And here is not a JavaScript because we don't have any we don't use now the correct tools to looking from this specifically information. And if you see here below, take a look at this, we still have the information about open action. But Filipi, what does that means open action? So let's check if I have this information here. I think I don't have these informations here. Yeah, we don't have her here, but I don't know if we have these informations here. I would like to share with you these information in more details. Let me check here if I have here this information. Or, oh yeah, I have here. Take a look this, what that means. Okay, nice. Oh, AA or open action indicate an automatic actions to be performed when the page or document is viewed. Take a look, this is important information. So indicate an automatic action to be performed when the page or document is viewed. So now take a look at this. The user or the recruiter or the talent acquisition person receive this resume or the CV, or if you of the people of the financial receiving specifically invoice, when they receive it by email, so they need to check this email, they need to open this PDF. So this is the action, open the page, view document, right? So this is the action, the normal action, view document. So after that, when you find this open action, it means that an automatic action will be performed when this page is open, okay? So it means that something will be happen after this view. And the combination of the automatic action and JavaScript makes a PDF document very suspicious. So what we have here, an open action is a JavaScript linked. Means it's a suspicious, it's malicious probably, right? So if you are analyst here, so we can check this information, we can agree with me that is totally malicious. But let's continue our investigation. Okay, so now we know what that means, the open action, and we need to find where this JavaScript. So take a look at this other object. Take a look at this font and research and image. On here, other research, other reference, object 8 and 9. Remember the picture, okay? Reference, linked, other object. So let me stop here the video. Remember this image here. Okay, it's not this image. Yeah, remember this image. So object 4 linked with another object. You see, and object 7 is referring object 10. You see the image? So many childs for the specifically object. You see how important to understand this? Nice. So in this reference, we have an object inside of this object 10. We have a possible JavaScript. So let's go more deeply on other informations of the body, other informations about the body. So let's see. Object 11. So remember, we have a 15 object. So inside of object 10, we have another reference object 12 here. And here is the first streaming, contain streaming. Not only that, but we have here the flat decode. So it means that we need to decode the content inside of this streaming. And here, as you can see, the length is 36. In this case, it's not too big, it's small, so maybe we don't have any important information here, but we have a two streaming here, so we need to find other streaming or what kind of information we can find here. So here we have another object. Take a look this. In object 11, referring an object 13, okay? Inside of this object 13, we have a what? We have a streaming. So inside of this streaming, we have a what? We have a JavaScript. So, and as you can see here, the length, when you compare to another, is too high. So it means that the JavaScript, probably malicious, we can find here in this specifically object. So this is, this should be our main object to investigate, okay? So we need to look more about that. So let's go to this specifically object, okay? So then another tool that I'm using here, it's PDFTK. What is a PDFTK? It's a handle tool for manipulating PDF, okay? Oh, it means you can using to, creating a PDF, a merge of different PDFs, collating PDF, and compress streaming pages and then compress or recompress. I mean, uncompress actually, or recompress. Remember, I have a content here inside of the streaming, so I need to uncompress this information. So that's my action here. So I have a PDF, CVE, the file, set the output, or I will copy this information I passed here in the doctext, and I will set the uncompress activity, because my idea is to looking for the deeply information, the content inside of this specifically streaming. Remember that in object 13. And here is the information is important we find. Object 13, the left, we have a content. This is the first technique used by the attacker, the JavaScript obfuscated. So here is the JavaScript, but this JavaScript is obfuscated. So you need to obfuscate this code. Basically, it's the second action. So remember, we have a PDF. This PDF has a JavaScript. Inside of this JavaScript, we have specifically open actions. Remember, when the user view this information, the attacker will use in a JavaScript, and here is the first technique used by the attacker, obfuscation technique using this specific. If you see here inside of this parentheses, you can see specifically standard number, like you see numbers and more below, or not below, but if you see here inside of the parentheses, as you can see here, letters, numbers, other informations, as you can see here. So kind of standard information. So after that, I need to disobfuscate this code. Remember, so if they use in obfuscation, I need to disobfuscate here. So I found here some specifically evil parameter, and my idea here, if I have a JavaScript, I will try to rewrite this information using HTML. Basically, this is the idea here. So I using this specifically copy and paste here to facilitate our demo. Okay, so I will copy here and I pass here the document right. So you see, I will disobfuscate this JavaScript, as you can see here. So this is the second action. So remember, the attacker using the obfuscation technique, I will disobfuscate this code. And let's see now what kind of information we can find here inside of this specifically code. So I will rewrite in the HTML file, I save, and after that, I give the permission to execute itself in the in a web browser, because my idea is to open here in the web browser, check what kind of information we can find here. Okay, so I'm using Firefox to call this sample, and let's see what happened now. Take a look this, and bam, we have a payload. You know what that means? So probably if you know, no problem, but the payload is a part of code, is a package responsible to download or to just download in the victim machine actually. And this package is responsible to execute the callback to the CNC, command and controller, to make a response to the attacker. Okay, so remember, inside of this streaming, remember, we have a JavaScript obfuscated. Inside of the JavaScript, we have a payload. This payload basically is the package that it will explore the victim machine. And after that, what I'm using here, I will see the standard, ladders and percent. I will copy and paste here, and I put in here in a specifically file. And my idea here is to try or to find in specifically information. I'm using sed to cut this information, because here we have now a pure code using by the attacker. The attacker using a specific Unicode technique to encode informations here. So, and not only that, but I using here in Unix platform, but I using here in Windows too, because I'd like to show you different approach, not only in Unix, but using Linux. So here's the same malware, the same artifact as you can see here. Take a look, this is the JavaScript obfuscated. And I will using here another platform in Windows platform to show you those differences, okay? So here is the real payload. Remember, I will copy, and I use sed when I use in the Linux platform. But here you're using Mozilla, okay? So I will copy here, and I will paste, and I will share with you here what kind of technique using by the attacker. Remember, I mentioned about specifically encode technique used by the attacker, because remember, we have a payload, and the attacker using specifically encoding technique to encode this content inside of this payload. And this encoding, this technique used by the attacker is using by UCS2. Okay, it's not new, it's old. Now the evolution, actually, we have a new UTF-16, UTF-32, and so on and so on. But before that, we had UCS2. It's old, okay? So I'm using here UCS2 to generate here. So I will basically to decode this information to generate a hexadecimal information, as you can see here. And now I have an hexadecimal file, okay? So after that, I generate this hexadecimal file in a binary. Why I do that? Because remember, but usually the most of malware, more than 90%, is for the Windows platform. So I generate this specifically binary to execute itself inside of the Windows machine. And after that, I use ensure to search for a possible HTTP protocol inside of this binary to see if this binary will call something. And take a look what I found here. I found the command and controller from the attacker. So now we have an CNC the attacker. Remember about the payload? Yes, the payload will be a callback for this specifically CNC. You see how interesting is? So if you pass here the IP address, you see this IP address is from Estonia, Europe, okay? So here, as you can see, this is the information we found in this specific file. So let me just to finalize this information. So if you see here, so many URLs related to this specific attack, and if you see here, so they have many victims machine explored by this specifically attack using PDF malicious. Okay, so just to summarize this demo, actually remember the user received this PDF. This PDF has a specifically JavaScript Inside of that, this PDF is, or was in this case, obfuscated, or JavaScript obfuscated. Inside of this JavaScript, remember this JavaScript is even the streaming, this content is inside of this streaming, and we disobfuscated this information. Inside of that, the attacker used a specifically encoding techniques. Actually, inside of the JavaScript, we have a payload. Remember, the payload is a package responsible for this callback, this information, to the victim machine, to the attacker. Remember that. Inside of this payload, we have another technique used by the attacker, this encoding technique using UCS2. And inside of that, we have an CNC responsible for this explanation, okay? So here I can suggest you some books if you'd like to read and study more about the malware analysis. So here are 4 books that I can recommend you, right, about the malware analysis techniques, threat hunt with elastic stack, and practical threat intelligence and data-driven threat hunting. So 4 very nice books that I can recommend you if you would like to read and study more about that. And that's it. So I finished my presentation here. I hope that I can help you during this journey in our conversation. So if you have any question, so please let me know, and see you in